Okay, this week we will talk about the autoencoder and its implementation on the PyTorch library, especially for the standard neural network structure and the convolutional neural network structure using the means database. Okay, the means database contains some different numbers, for example 1 to 9. Okay, and then we will feed the autoencoder with the numbers or the image vectors, and then we will produce to the same image at the end of this code. But what is autoencoder? This is the first topic of this lesson. Okay, so we need to firstly give the head title of the introduction to AI. Okay, so this another head title is the autoencoder. Okay, so firstly we need to suppose that we have n, like for example 3 input neurons is given in here, x1, x2 and x3. Okay, and so we can build some another neurons in here like this one, and after that we can generate the one output y. Okay, that's the output of this neural network. Okay, and so we can say that we can build a map between the x vector to y vector. Okay, and so this simply represents this function y is equal to the f(x) vector. Okay, in this generation we only utilize, or we only decided to the signal generation like the y or classification task can be accomplished by using these terms. Okay, this is the standard neural network structure for the for regression operation and the classification operation. But we need to talk about some other feature which is given in the machine learning applications. For example, we do not know the general mechanism of this hidden layer structure. For example, we know that the x1, x2 and x3 are the input variable and y is the output, but we don't know yet about what is accomplished by the neural network structure in here. Okay, we cannot model it, we cannot represent, or we cannot visualize the whole coefficients by using these terms. Okay, but this is some basic feature. However, we don't know the unknown representation of neurons and the hidden layer in here. Okay, and so which we don't know anything about the x1, x2 and x3. We just only use the x1, x2 and x3 as an input vector, as a number, but we don't know the characteristics of the x1, x2 and x3 or the y. Okay, we just simply take that we build the f function with an input x and we generate the y. That's simple. Okay, and so another term is the optimization is built in this generation for only target class or vector. Okay, because if we have the x vector in here and then we can only just produce the y vector, nothing more. Okay, and this neural network structure has the property of the supervised learning. Which means that this vector is only contained, or the only current for the application of what if we have the y target values. Okay? The standard neural network applications or the standard CNN application or any other application just taking the what three basic conditions. We don't know the neurons and the hidden layers. We don't know the representation of these terms. Optimization is built for only target vector, and we have the supervised learning in here. But what happens if I choose to model the input data in here in order to learn the characteristics of these terms in here? We cannot build any structure to catch the main features of the x1, x2 and x3 by using only this neural network application, because we cannot code the input and output data in here in a simple manner. Cannot code input output. Classification and regression is different from the coding, because in the coding we generate or we learn the internal structure of the input and output parameters. Okay? But in standard neural network structure we have only a function to produce the sum vector, but desired vector. Okay? We cannot learn anything about the input vector or the output vector in this case. So cannot reach to input features in this case, and also we cannot build the main features of input or output vector. Yes, this classical CNN structure gives us only we have input data, we can generate output data. Just simple. We have only two options, either regression or the classification. That's simple. Okay? And so we need to define the problem in here in order to understand the autoencoder structure. Problem is that we have assumed that three signals which is coming from the this representation. For example, this is the n sample of these terms, and we have the one signal in here like this one, and the other one is one, the other one is this one. Okay? And so we can assign any bias value in here 2, 5 and 12 values. Okay? And this signal is around the 12 values at this case. And so we can easily see that actually we have the one main components in here, like this one, mean values, right? Just remember that in the Gaussian distributions or any other distribution model, for example normal distribution, we just create the model to the mean and standard deviation values, right? And so by observing this data, we just simply decided that this signal is actually as a bias value with the values of the 2, 5 and 12, right? Yes, this is just like the bias values. This is the input data, x1, x2 and x3, and the other parts are actually a noise, right? Because its simple effects are on this signal, right? The only parameter of these terms of the mean values of this signal. And also these mean values represent the main feature of this signal, right? The other terms are considered as a noise value because it does not affect anything about the output values for this case, right? But we cannot see this value. But how come, or how overcome that if we don't observe easily in this data? For example, if you take an image with the values of the 2, right? It's the grayscale code, and we can deduce that we have some representation characteristic, but it's not easily seen by the eyes, or multidimensional vectors are considered in that case. And so, how can we find this kind of main components for a given signals, for a given input? This is our problem, because we know that every signal has a part of the main components and the other unwanted components. Just simple as that, right? And so this mean value or the standard deviation value must be found out by some algorithms to process any data or any models. This is our problem, because in the previous case we just used the neural network to only use the regression and the classification task. We don't know anything about the input data or output data, or its underlying mechanism about the input and output data, right? How can we do that? Our solution is that firstly, we need to understand the coding in terms of the input and output. Coding is given by if we have any model in here, like this one, x vector, and if we have any neural network application, we just take the same x vector is in here, right? If we feed the x vector to the neural network, and then we can produce the same x vector, or we must produce the same vector in order to in order to catch the whole features or the main features in here. Yes, it's kind of the reverse engineering, because if you know that our model is true, and then we can say that if we put or feed the x vector, and this neural network process the whole information, and then we generate our output as an input. And so we can easily say that this NN takes the main features of this vector or this input values, because it can generate again these values in a reverse order, right? Okay. So in order to do that, we need to understand that if we have, for example, this n and x values in here, and if we have this signal, bias value is the main part of our signal, but we also have a noise values in here, and the total collective function is given by this red one, right? But we need to find out these bias values in here, and this neural network can generate these two in the internal characteristics to find out the general mechanism, or to reproduce our x vector at the output, right? And so this is called the representative part. This black line is called representative parts. Okay? This code in the literature, we can say this is representative, this is the explainable, or this signal is the main component of our input. This is the main feature. Like Mehmet, right? Every person is given in here. So you are human, I'm a human. But I have some specific information. My name is Mehmet. This is just kind of the two values, the mean values in here, right? Okay? And so how can the algorithms or the machine learning algorithm find out this information for a given input data or input data set which is given in here? Okay. Firstly, we just use the neural network in here with the representation of these terms like this one. I can generate, or I can use this structure, for example x3, x2 and x1, and after that at the output of this algorithm I can reach the x1, x3 and x2, right? We have some connections in here like this one. This is the basic information about the Wellington neural network with the parameters of these terms, but at the output we have the same input. In the input values or input layer we have the inputs, but the hidden layer is also has the equal number of these terms x1, x2 and x3. We have 3 neuron, 3 neuron and 3 neuron at each layer. Okay. And so how can we minimize this algorithm? If we minimize the error is equal to 1 divided by 2 x target minus xi at each case. This x target is generated from in here like this one. Okay, x target. And so yes, x target is the input values, but if we feed the x1, x2 and x3, if we don't know the coefficients of these neurons, and then we cannot produce these terms. But if we are building this kind of algorithm, we cannot minimize this system because this system is already minimized. Why? This system cannot be minimized because yes, but we have the bias value in here, bias value 1, x1 transform this term b1 1 and b2 2, b2 equal 2, and then we just multiply these terms at each case, and then we can transfer the whole information with only bias values in here. We cannot learn this parameter because every coefficients are equal to 0 in here except the bias coefficients. You understand what I'm saying in here? We don't know the training first because we cannot train this term. Okay? We cannot train. In the second case, it is the case. So this is important to understand this in here. Okay? And so in the neuron structure, we have the just kind of information, right? Exponential omega t x plus b times x0, right? x0 is 1 and it's equal 1, and so this term is always 0 because we cannot learn these parameters or this effect because each parameter in here, x1, x2 and x3 are mutually independent from each other. Okay? And so we cannot learn anything about from these terms. But what happens if I choose x1, x2 and x3? And so if I increase the number of neurons at the hidden layer like this one, up to the 10 or 20 or another else, and if we can produce the x1 target, x2 target and x3 target, what happens if I choose to produce this neural network? Firstly, you need to understand that we have the 3D data in here, x1, x2 and x3. We have the volume values of these terms in here, and at the output values we have the 3D information as well, right? In the neural network, x1, x2 and x3 can be generated, but in the internal layers we have the higher formation of these terms, higher dimension. And so this higher dimension, or if we minimize this system, minimize the error, No, it's not directly true, because if we have this bias value in here, like this one, this is the what? This is the mean value. In the higher dimension, we always find out this mean value with the additional noise value plus noise value in here. And so we model the whole signal, but we cannot decide which part is noise or either the mean values or the representative part. We cannot do that. If I use the higher dimension in the hidden layers, and we cannot decide which part is the mean or which part is the noise value. We cannot get the informative or the representative information by using these terms. We cannot force the neural network in here. And so, in the last option, we have this kind of information. Firstly, we have the x1, x2, and x3, and x3, and we can generate these terms in here like this one. But at every case, we can decrease the values of the neuron. After that, we can generate some more neurons in here like this one. And after that, we can generate the x1, x2, and x3. In this structure, for example, we have 10 neurons, 5 neurons, 3 neurons, and 2 neurons, 3 neurons, 5 neurons, and 10 neurons. In this case, our algorithm are forced to represent or to code these values, because at each case, this x1, x2, and x3 is up to 10 values in here. But after that, we reduce the number of this neuron representation. And after that, we reduce to 3. And at the last case, we drive the 2, which means that if we have the x1 and x2 and x3, if we have the 3 features, and this 3 feature must be contained in in this section, because this is the representative part of our algorithms. This could be, or this must be contained in these neurons, or otherwise we cannot model it, right? Because if the representative part is in here, and if we feed this layer, and this layer, we can generate x1, x2, and x3. The only condition is that. Do you understand what's the underlying mechanism of these terms? If we are using the x1, x2, and x3, for example, in the first layer we can use the 10 neurons, and we have higher dimensions. But at each case, we we decrease the neurons. In order to build our representative part. If the train is accomplished in here, and so these terms must always be representative, because otherwise we cannot directly represent the x1, x2, and x3 in here. We are forced to the neural network to get the basic notation or the semantic meaning of this data or the mean values of these terms. Do you have any question? You understand what I'm saying? If I choose the higher number of neurons, we can produce these values. But in this case, we just only model these terms. Otherwise, we cannot generate x1, x2, and x3, because this is the main components. And this term should be modeled by using these terms in the training phase. Yes, because in this 2 neuron or 3 neuron structure, we just generate the important part of this x1, x2, and x3. Otherwise, this neural network cannot be modeled or cannot generate the x1, x2, and x3. we force the neural network to learn it. Okay? And so, in the autoencoder structures, we just say that for this assumption, we can give the generalized form of these terms, like this one. If we have any input in here, x1, x2, x3, blah blah blah, xn can be given in here, and if we are using the neural network, at each case we decrease the number of neurons like this one, and after that we can generate the some patterns in here with the neurons, but the smallest number of neurons can be considered in here. After that, if we grow the neural network with the identical features, and after that x1, x2, x3, x4, blah blah blah, and xn can be generated in here, and then yes, it must be, because if we choose this neural network is higher than the input layer, and then we cannot model it, because we generate for one signal to 2 neurons in this case. But in this case, in our cases, we compress the whole data into the smaller number of neurons, and the most important one must be modeled in this neuron in order to generate the output layer with the same number and the same features of the x1, x2, and x3. Okay? This is called the autoencoder structure. Okay? And in the first place, we should say that this terms is called the encoder, encoding the whole data. We just use the x1, x2, and x3, and blah blah xn to encode the some space, but the smallest space, the meaningful space or representative space, which we call it the latent space. In Turkish meaning, saklı, gizli katman. This is called the latent space, embedding space. We code every data to to this smallest number of the neurons. After that, we should decode this information. Decoder is called at this stage, because we just use the 3 neuron or 3 output or 4 output at the latent space, and we should generate by using just 3 outputs. If the decoder is used in here, these 3 outputs is transformed into the 1000 outputs, because it's the main characteristics of the x2, x1, and x3. Okay? And the encoder and decoder are utilized to this space, and this latent space contains the main features or the main characteristics of these terms. If I use this algorithm, I can learn the input data features by using these terms. Okay? This is the basic idea or the behind idea about the autoencoder structures. Okay? Any question? If you don't have any question, we just create the 2 examples in here. Okay? But after the 10 minutes break. Okay?